This conversation is powered by Google Illuminate. Check out illuminate.google.com for more. Welcome to this discussion. Today, we're delving into a research paper titled MI9 Agent Intelligence Protocol, Runtime Governance for Agentic AI Systems. This paper proposes a novel framework for governing the increasingly complex and autonomous behavior of AI agents. Let's start with the core problem. What are the unique governance challenges posed by agentic AI systems that traditional methods fail to address?
Traditional AI governance focuses heavily on pre-deployment controls such as model training and validation. However, agentic AI systems capable of reasoning, planning, and executing actions autonomously exhibit emergent and unpredictable behaviors during runtime. These behaviors, including recursive planning loops, goal drift, and cascading tool chains, cannot be fully anticipated or controlled through pre-deployment methods alone. This necessitates a runtime governance framework.
The paper introduces MI9 as a solution. Can you outline the key components of this framework and how they work together?
MI9 is a fully integrated runtime governance framework comprising 6 components. First, the Agency Risk Index, ARI, quantifies the risk posed by an agent based on its autonomy, adaptability, and continuity. This risk score then determines the intensity of governance applied. Second, the Agentic Telemetry Schema, ATS, captures agent behavior, providing crucial visibility into cognitive processes, actions, and coordination events. Third, Continuous Authorization Monitoring, FSM, dynamically adjusts permissions based on the agent's current state and actions. Fourth, the Conformance Engine uses finite state machines, FSMs, to enforce temporal policies and detect violations in multi-step workflows. Fifth, the drift detection component identifies concerning behavioral changes by comparing current behavior to goal-conditioned baselines. Finally, graduated containment strategies provide a tiered approach to intervention, ranging from increased monitoring to complete isolation, depending on the severity of the risk.
The ARI is a crucial component. How does it effectively quantify the risk associated with different agents?
The ARI uses a 3-dimensional scoring system: autonomy, adaptability, and continuity. Each dimension is further broken down into 4 criteria, each scored from 0 to 3. These scores are then combined to create a normalized ARI value between 0 and 1. This value is then mapped to 4 governance tiers, with higher tiers triggering more stringent oversight. The equal weighting of the dimensions reflects the understanding that different aspects of agency pose distinct governance challenges.
The paper emphasizes the importance of agent semantic telemetry. Why is this crucial, and how does ATS address the limitations of traditional monitoring?
Traditional monitoring focuses on infrastructure-level metrics, missing the crucial cognitive processes driving agent behavior. ATS addresses this by capturing agent semantic events, classifying them into cognitive events, internal reasoning, action events, environment interactions, and coordination events, multi-agent interactions. This provides a much richer understanding of the agent's decision-making process, enabling more effective governance.
CAM is presented as a significant improvement over traditional RBSE. What are the key innovations that make it suitable for agentic AI?
CAM moves beyond static role-based access control by incorporating context-dependent permissions, delegation chain management, and real-time policy enforcement. It dynamically adjusts permissions based on the agent's current state, goals, and execution history, preventing privilege escalation and ensuring that access rights remain appropriate throughout the agent's lifecycle.
The Conformance Engine uses FSMs. How does this approach improve upon simpler rule-based systems?
FSMs allow for the enforcement of temporal policies, capturing the sequential nature of many risky agent behaviors. Simple rule-based systems often fail to detect violations that span multiple steps. The FSM approach provides a more robust and expressive way to define and enforce complex behavioral constraints.
The paper highlights the challenge of distinguishing between legitimate adaptation and concerning drift. How does MI9's drift detection mechanism address this?
MI9's drift detection uses goal-conditioned baselines. It establishes expected behavior patterns for specific agent objectives, allowing it to differentiate between beneficial adaptation within a goal and concerning deviations. This goal awareness is crucial to avoid false positives. Statistical methods such as Jensen-Shannon diversions and Mann-Whitney U-tests are used to quantify deviations from these baselines.
The graduated containment strategy seems particularly important. How does it mitigate the risks associated with abrupt agent termination?
Abrupt termination can be disastrous with agentic AI, potentially leading to cascading failures. MI9's graduated containment offers a tiered approach, starting with increased monitoring and progression to more restrictive measures like planning intervention, tool restriction, and finally, execution isolation. This allows for a more nuanced response, preserving operational value while mitigating risk.
The table mentions a synthetic evaluation using simulated agent traces. What are the strengths and limitations of this approach?
Synthetic evaluation allows for systematic testing of various failure modes and edge cases that might be difficult or impossible to observe in real-world data. It provides a controlled and reproducible environment for validating the framework's effectiveness. However, it cannot fully capture the complexity and unpredictability of real-world agent behavior. Real-world validation is crucial for confirming the framework's performance in diverse and dynamic environments.
The evaluation results show MI9 outperforming other frameworks. What are the key factors contributing to this superior performance?
MI9's superior performance stems from its integrated design and agent semantic focus. Other frameworks often lack the comprehensive telemetry and real-time intervention capabilities that MI9 provides. The integrated nature of MI9 allows for a more holistic and effective governance approach.
The paper concludes by acknowledging limitations, such as the dependence on comprehensive instrumentation and potential computational overhead. How can these challenges be addressed in future work?
Addressing these challenges requires further research into efficient telemetry collection methods, particularly for agents with opaque APIs. Optimization techniques are needed to minimize the computational overhead of real-time monitoring, especially in high-throughput deployments. Furthermore, security considerations are paramount. The framework itself presents a potential attack surface, requiring robust security measures and adversarial testing.
The paper also mentions the need for real-world validation. What would be the key aspects to focus on during such validation?
Real-world validation should focus on deploying MI9 in diverse production environments across different agent architectures and use cases. This would involve monitoring its performance and handling unexpected behaviors, evaluating its effectiveness in preventing or mitigating real-world risks, and assessing its scalability and robustness in high-stakes scenarios. Careful analysis of false positives and negatives would also be crucial.
Finally, what are broader implications of MI9 for the responsible development and deployment of agentic AI systems?
MI9 represents a significant step towards establishing a robust framework for the safe and responsible deployment of agentic AI. By providing a comprehensive and integrated approach to runtime governance, it addresses the critical gap between pre-deployment controls and reactive post-incident analysis. Its adoption could significantly reduce the risks associated with increasingly autonomous AI systems, paving the way for wider adoption and trust in this transformative technology.
Thank you for this insightful discussion. This has been a comprehensive overview of the MI9 framework and its potential impact on the field of AI governance.